15 questions were about molarity, and I was like, we never even learned this.
Oh, when's it due?
It's due on Monday, so it's fine.
Don't we have the exam on Thursday,
It's
though?
gonna be like next. Yeah.
Yeah, I think we'll
Why
have
is
it.
it due after the exam?
I don't know. That's a good question to ask. Hello. Oh, yeah. Also, please sign. You didn't sign last time, and so I had to sign for you.
Sorry.
It's okay. How are you doing, Kripa? Good. How are you doing, Mom? How are you doing, Lamb?
The XO2 model on your spreadsheet, is there supposed to be double bonds between S and O?
One of them.
But wouldn't the common charge be lower if it's both of them?
Hundreds. So SO2, how many electrons does sulfur have? 18 in total, right? So if you had double bonds on the oxygen, right? How many electrons would you have used?
8.
You would use 8 on each of the oxygens, right? Total of 16 is still. Oh, yeah.
And then
Oh, yeah. Did I make that mistake? That's my bad. Sorry, guys. Oh, I'm thinking of sulfite. Sulfite is like that. Maybe. I don't know. I might be wrong. I'll figure it out. Sulfur dioxide. Okay. How you doing, Spiro? Good. How are you? Doing good. I'm doing good. We got back an Oracle test today. 10, bro. I'm so happy.
You did well?
I did well. So basically, like you kind of have the same situation as you guys where like you can drop the third test. Yeah. So did well in the first 2 tests. So I can drop the third test if I want to. So I'm in a good position. That's what I got.
Are you gonna hand in like the paper with your name and that's it?
Huh?
Like for the third test?
I might not show up. It depends. You can do that. It's not high school. So I don't know if there's anyone joining on Zoom, which is good if no one joined on Zoom, because then I don't need to worry about them. I get nervous by the people on Zoom. I don't know why I'm showing this. You know, it's weird. Like I showed this last week and it stayed on here, and that's not supposed to happen. But let's look at sulfur dioxide. Sulfur dioxide. I must have made a mistake. Yeah, but I made a mistake. I'm sorry, Molly. Where did I do that? Was it on the review sheet that I sent? Here, show me. Yes, I made an error.
This is number 8.
For which ones?
What are we doing ones?
Hello.
Perfect.
Okay.
I have many questions.
Okay, yeah, let me know what they are right now. What's the questions?
I need to go over all of modules.
All of module 6, that's a very hefty task.
With mole.
Start with moles. I don't know. Do you guys listen to Tyler the Creator? Do you guys listen to Tyler the Creator? He came out with an album today. I'm so happy. Okay. Anyways, no one replied to that. Okay. Yikes. Okay. Oh, this is Orgo. I'm sorry, guys. Don't look at this. You guys are gonna get scared. Yeah, no chemistry.
What's your GPA?
No comment. Can't go around
2.99.
talking about GPAs like that. Okay. So I'll do a very brief rundown of module 6 because module 6 is really important for everything in
Calculation.
I understand what's on the slides. I don't understand like some of the questions on like our active.
Okay. That's no problem. Module 6
Like I
solutions. Okay. Let's think. How can I do this? Okay. We'll do a quick rundown of module 6 up until molarity, because you guys haven't learned molarity yet. Isomerics, blah, 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 blah.
Like how,
Hey, Devinder.
the question was like how many physical units are in like however many grams of something. Yeah, I know.
Oh, so formula units is just another way of saying atoms, yes.
Then how do you get from that to gram?
That's grams.
I
Okay.
mean, grams to
Can't
that.
you go from the beginning?
Yeah, okay. Are you guys down with me? I'm gonna quickly run through
Okay, this side.
all of like this stuff very, very briefly, okay? So we have this thing called a mole. Okay? Not like those things that come out of the ground, but like a mole is just like a kind of an abstract value that chemists have used to define like should make a conversion factor. So think of a mole as kind of like 12 inches equals 1 foot, right? But the difference is that a mole itself can be varied, basically. Okay. So I'll just make an example, right? So we have grams. You can use the molar masses from the periodic. Make sure you guys print out the periodic table and practice with the periodic table. Please. You guys have the periodic table with you guys? Please print it. If you guys are struggling with like doing all this stuff, I recommend printing out because it's very important because I'm gonna be jumping around with all these different units and numbers and stuff. And it's good to know that. But basically, right, you can go from grams to mole, and then from mole you can go to what's it called? Molecule slash formula unit. With this, you go with grams per mole, that's the molar mass. That's the unit of molar mass. And from this, you go use Avogadro's constant, which is 6.023 times 10 to the 23. This or this over mole. Okay, so that's the conversions, right? It's very, if you guys actually like think about it, it's very similar to like converting days to time. So like, let's do a quick one, right? Let's do 2.2 days. Let's calculate that into seconds. What's the conversion for days to an hour? Can anyone tell me? How many days are in 1 hour? I mean, no, how many hours are in 1 day? 24, right? So you would want to go down here, 1 day, 24. We do this because this is called cross multiplication. I mean, this is dimensional analysis. Days cancel out, right? Same thing. Now, how many minutes are in 1 hour? 60. So 60 minutes are in 1 hour, right? And then how many seconds are in a minute? 60 seconds, right? So then what you would want to do is you want to use your calculator and calculate that, right? And it's actually very simple. All you have to do is like 2.2 times 24 times 60 times 60 because all these are 1, right? But basically, that's essentially what's happening with this, right? We're going from, let's use carbon. Carbon's molar mass is, if you look at the periodic table, carbon's molar mass is 12.011. I think you guys will just use 12.1. And what this means is for every 1 mole of carbon, there's 12.01 grams. That's the molar mass of carbon. So let's say we have 6.7 grams of carbon, and we're trying to convert to molecules of carbon. How do we do that? So what we want to do is you want to take the molar mass, and so for this case, the molar mass of just 1 carbon mole is 12.01 grams. So now what you want to do is you want to do 1 mole over so I'm also showing you guys I like to do things all in one step because I don't like to deal with the sig figs. And also because your test is multiple choice, you're gonna want to deal with everything in like kind of one step because it will make it a lot easier. Also, yeah, you don't need to worry about sig figs. That's pretty nice. But anyways, right? So 12.01 grams, right? I'm getting this value from the periodic table. All right. So this is the molar mass of carbon. And so from there you convert and you get moles, right? And then from there, what you want to do is you want to take this ratio and then do 1 mole over 6.023 times 10 to the 23 atoms. Okay. And then when you put this in the calculator, you should get your answer. Yeah.
So for what kind of problems do you have finding?
So anytime that there's like a question about a mole and stuff like that, you need to like basically kind of understand these different different relationships, because just like how we went from mole to molecule, we might need to go from molecule to mole or mole to gram or whatever, right? Or gram to mole. And from the practice quiz that I sent, you'll start to see a lot of those things that you're gonna need to do. A lot of the questions that I put on the practice quiz are very heavily inspired by last year's quiz questions. So got you guys. But anyways, let's do one more problem. Or I mean, pull out your graphing calculators or whatever. I want you guys to practice actually like doing the calculations, because that's half the battle, you know? You don't want to like, you have ample amount of time to do this, but it's also important to really like be proficient in calculating this, because that's the most important step in getting the calculation right. The way that I would put this in the calculator is I put 6.7, right? And then I do 1 divided by 12.01. And then I do 6.023 times 10 to the 23rd. I do it like that. It makes things a lot faster. It makes things quicker, you know? I don't know how many questions you guys are gonna have in your tests. How many questions do you guys have in your last test? 40. 40? Ooh. Oh no, that's not good. So you guys really gotta get going, even though they are multiple choice questions, and multiple choice questions, you have a ton of different ways to solve them. It's important to be able to get through these quickly. Okay? So this is how I like to solve it. You guys can do it however you want to, but I think that it's better to do things fastly and correctly than slowly and slightly correctly. So yeah. All right. So that's basically like what the beginning of module 6 was all about. It's about converting moles to using the mole ratio, the mole conversion stuff to calculate whatever. Obviously, carbon's a very simple one, so let's do a different one. Let's do let's go with does anyone want to give me a good molecule? Maybe I know the name, the molar mass of that molecule. Chlorine. Chlorine's 35.45, right? Is it? Yeah, okay. Let's do I don't know. Let's do NaCl. NaCl. All right. What's the molar mass of sodium? Anyone know? 22.99. All right. That's from the periodic table. It's not supposed to be you guys just check the periodic table. You don't need to memorize it like me. 35.45 is chlorine. Add them up. I don't 4, 1, 4, 8, 5, right? All right. Thank God. Okay. Hello. Did you sign? You didn't sign either last week.
My bad.
Okay, thank you. Okay, so that's the molar mass of sodium chloride, right? So let's calculate. Let's do 5.73 times 10 to the 42 formula units to grams. Let's do that. So we're going from formula units to grams. So can anyone tell me what the first conversion factor is that we're gonna use? Anyone besides Devinder? We're converting formula units of NaCl. Yeah, good. So another way I like to write it out is because of dimensional analysis, right? You want to write 1 mole over 6.023 times 10 to the 23 formula units. Why am I doing it like that? Yeah, because it shows that you're canceling this out, you're doing all the work correctly.
I know how to go that way. I just don't know how to go first, like the other.
The other way,
Which is
grams.
literally the opposite, but I don't know.
Wait, grams to molecules? The one we did before?
Yeah.
Okay, well, I mean, this should also show, doing the dimensional analysis can help you check that, because dimensional analysis can show you, okay, I'm crossing out this unit. What's the next conversion factor? Can anyone tell me?
The number of grams of the molecule per mole.
Yes, so that's the molar mass of the molecule. Now what you want to do is you want to take the mole and you want to put the molar mass, which is right here. We calculated that, 58.44 grams, and you see how it cancels out with the mole, and then you're left with grams. So the reason I like doing this as well is because it really shows that you're doing the calculation correctly while showing you what the units are, how the units are canceling out. Yeah, there's some beauty in math and stuff like that. All right. Are you guys chilling so far? You guys understand? That's good. Good. What am I trying to do? Oh yeah, let me pull out my calculator so that I can join you. All right, so that's basically the beginning of this whole thing. Empirical formula we're gonna get into a little bit today. Formula unit mass. Formula mass is basically the same thing as saying molar mass. I just like to say sometimes they say formula mass, but there could be a question of like that. So yeah, mole is very subjective because on the periodic table you have different quantities for moles, right? You have 22.99 for sodium, you have 12.011 grams for every carbon. It doesn't really matter. What matters is just reading the periodic table and understanding what you're reading when you see that. But yeah. You guys have any more questions about it?
I have a question about the Lewis structure of NO2.
NO2? Yeah, sure. So NO2, there's no charge on it? NO2, there's no charge on it. Dioxide. 5 plus 12 and 17. So it's gonna have an odd number. Yeah, this one has 17 electrons, so it's gonna be weird. So let's see.
CO. And that's all divided by the mass.
So you did it the same way in class, but you could also do it. Same time.
It's not super valuable.
Yeah, but the thing is that single bond,
Nitrogen-based.
because it minimizes the formal charge of nitrogen. So there's
Have one
16,
more
16.
electron.
Yeah, so that's nitrogen dioxide. It's weird. That's weird. I don't like looking at that.
But can you also go over like the polar diagram?
Polar diagram,
Yeah, like the molecules draw the diagram.
like all the molecular geometries are polar.
She would like how to find if it's polar or not. Like.
Okay. Yeah, so a good rule of thumb is anytime you hear planar, think non-polar. Planar is non-polar. The only exceptions to that are if they're connected to some different electronegative thing. You guys are gonna have access to the electronegativity values on the thing. So for example, boron, trihydride, right? So this is the molecule for BH3. Okay, so the reason why it's non-polar is because if you were to look at this in a three-dimensional plane, all of these are actually getting slightly pulled by the boron, like in all equal directions. So like this would be non-polar because of that. Now, if there was a fluorine added to this, so like let's say there was a fluorine here, right? Everything is now getting pulled towards the fluorine. So then that would make it polar. All right, so but generally, if you see a molecule that has the same atoms, right? And like the same, like a different central atom, right? You can assume by the geometry that it's gonna be like non-polar. And so stuff like trigonal planar, square planar, those will be non-polar. Tetrahedral, trigonal planar, linear. All the ones at the top are like, yeah, all the ones that are like the base stuff, those are gonna be non-polar. Which one? Carbonate. All right, let's do the Lewis structure for that. So carbonate is CO3 minus 2. What's the valence electrons for carbon? 4. What's the valence electrons of oxygen? 6 times 3 plus 2 because of the -2 charge. Don't forget that. That's very important. 18, 22, 24 electrons, right? Yes, good math. Okay. So carbon, oxygen, one probably has that. 2, 3, 4. Did I put something on on the thing? Did I make mistakes or on where? Let's think about this. No, it wouldn't be polar because they're all like, what's it called? It wouldn't be polar. So basically ions are like weird. Carbonates, because it has a charge, it kind of is, it's not that it's just an ion. So don't worry, they're not gonna ask a question like that. It's because it's an ion that basically because it's an ion, it has like a negative charge, whatever. So like it has ion dipole reaction. It's a whole thing, don't worry. Yeah, I'm sorry. I'm human, I make mistakes. But anyways, that's okay. So anyways, there's a minus here. Stop, yeah.
Can you go over how to draw like correct resonance structure?
Sure.
Like on section 5, like module 5, the second practice problem.
Yeah, sure. Sounds good. Which one?
Section, like module 5.
Module 5, this one, or is it this one?
No. Module 5,
Module 5.
it's that one.
I didn't know there was resonance structures in this. Okay, let's see.
Yeah, that one.
This one? Okay, so let's do sulfur dioxide. Look at that, we made a full circle, come on. All right, so. Okay. Okay, so let's do sulfur dioxide. So how many electrons are in sulfur? Sulfur is right under oxygen, so how many valence electrons are there? 6. Good. I'm glad that you guys are getting the hang of it. That's half the battle. What's the amount of valence electrons in oxygen? 6. Good. I know it's repetitive, but you guys have a test on it, so. So sulfur, oxygen.
How do you know they're two double?
I don't know, but I do know that, I mean, you could test it, so you could do like this and see whatever. And this would work, but the thing is that, to minimize the formal charge, oxygen would like to have 2 bonds, because, if it has 2 bonds, it would be 6 minus 2 minus 4, in terms of like the valence electrons, right? So if it's 0, right, what's the formal charge of this?
The oxygen,
Yeah, what's the formal charge of the oxygen?
a negative 2. Oh, you're saying 6 minus 4.
Yeah.
6 minus 4 minus 2.
Yeah.
Negative 2.
For
Oh, 0.
yeah, this one would be 0, but then this one would just be -1. So the reason why I'm adding a double bond is because adding the double bond minimizes the formal charge. Because instead of it being 6 minus 2 minus 4, it'd be 6 minus 6 minus
You
1.
have to do that for all. Is
Not
there,
for
like,
all
a
of them, but the
general-
ones that apply, the ones that you can do. You have to make sure you have the right number of like electrons you count and make sure that everything's all good. Don't worry, we'll get to some examples maybe. Okay. So again, right? Boom, boom, boom. Okay, so how many electrons is this?
8.
8. How many electrons is this? Okay, so then you add that. So then the actual structure would be something like this. Okay, and then is there any resonance structures? You could draw one where it's like this. And then it's like. So resonance, all that means is that you're moving electrons, right? And so basically. This could be a resonance structure. It's not a good resonance structure. This is the major contributor because it has it minimizes all the formal charges. The other one is
So-
this here. That's,
For resonance structures, like let's say like that second one, they don't need to have minimized charges.
yeah, resonance structures, yeah, generally they don't have to have minimized charges, you can just move around electrons and stuff like that, but as long as generally the octet rule remains consistent in most of them, like. I'm trying to use my words wisely. Because sulfur has hypervalence, so technically oxygen, the bonds could go on sulfur too, but I don't know. I think he post the answers to this question? He did post the answers. How many, you guys, can you guys check that real quick? Tell me how many things there are that he put there. I guess you could do this too. You have to make sure that all the electrons equal the total number of electrons you put there. So I think there's 4 structures, but. But 3. Yeah, I could really. Reach what? Mhm. Wow, this is. Yeah, resonance structures are not my thing. I'm good at Virgo resonance structures, but that's not Gen Chem. I don't know, that's a little sus. A little sus, guys. It's weird.
Draw the structure of xenon dioxide.
Xenon dioxide, that's a good question. Xenon dioxide, what's the valence electrons for xenon?
8.
8. What's the valence electron for oxygen?
6.
6 times 2, so 12, 20 electrons in total, right? Xenon. Okay, I used, how many electrons did I use?
16.
16. So 4 more electrons would be left, so you put them on the hypervalent. So it's bent, just like H12.
So, okay, because on your answer key, you put a single bond for both oxygens, so I was just curious.
Did I really? Oh no. Oh no, that's not good. I must have been rushing.
Because I mean, it
Guys,
makes,
I'm just gonna be very transparent with you. The last 3 weeks, I've had a test in every class. I had a test in genetics. Last week I had a test in orgo. This week I had a test in physics. Please bear with me, guys. I'm trying my best to be here for you guys. I was actually considering being an SI next semester, but I don't know. We'll see how it goes.
Don't say that.
What do you mean, don't say that? Aw. Okay, but sulfur dioxide, let's see. Acetate ion, acetate, this is a polyatomic you have to know. Let's see this one. This one's more orgo, so this makes me happy. Acetate. This would be like this. Okay, so then the resonance could be like. And then it's up here where it's like. You guys need to talk more. I feel like you guys don't talk at all. Makes me feel topics of me talking. Anyways, that's the resonance structure. I think that's.
Why is sulfur or
Are you guys looking at the module review sheet that I sent?
no?
Oh, that's a different one. Sulfur tetrachloride. All right, let's draw the structure.
That's like it's tetra.
Well, no, that's not. So that's a prefix, right? So sulfur tetrachloride, that's the naming.
Yeah.
But what's the actual structure? So
Organelles.
is it? That's electron arrangement.
Uh-huh.
But then what's the actual structure?
How-
You gotta draw it out, right?
I
So
mean, seesaw.
sulfur, it's seesaw, right? Seesaw would be polar. So that's a
Wait,
good
it's
one.
like the, okay, but when you look at the table, sulfur and fluorine are like, they have a 0.5.
Okay, well, let's do it, right? So this is sulfur. Here, let's move to the middle. I'm moving all the way to the left. Oh, these are good questions. This is what the session's supposed to be, guys. Like, I'm glad that you guys are all coming here. You guys are having questions. You guys know this shouldn't be considered like a competitive program. You guys can all work together, collaborate. You know, you guys are in this for the long haul. You guys are going to be together for 7 years. Yeah, peruse. Okay, so how many electrons are in sulfur?
6,
6. How many electrons are in chlorine?
7.
All right, 7 times 4, right? 28, 34, right? Right, guys? Did I do the math right? I will be doing this. Okay. Okay, so halides tend to form single bonds. So chlorine. I'm only drawing like this because I know she told me it's gonna be seesaw, but yeah, 1, 2, 3, 4. So there's gonna be 8 electrons, 32 electrons in total that are gonna be used. All right. I hope you guys are pros at this because there's some crazy stuff. Okay, so then you put the lone pair here, and it's seesaw, right? Looks like a seesaw. You guys remember what the name for 3 atoms, 2 lone pairs is? T-shaped, yeah. 3, 2, T. 3, 2, T. 3, 2, T. That's the way I know everything. All right. Any other questions?
Yeah.
I'm gonna hand mine's polar.
Oh, why it's polar? It's because generally, right, what's happening with this lone pair is that there's creating a lot of repulsion. So that because what that causes is the chlorines kind of go down a bit.
So
And
not-
so like, what's that?
So it's not symmetrical and they don't count.
Yeah, it's not asymmetrical. So then there's more, I don't know how electronegative it is. How electronegative, which one's more electronegative, sulfur or what? Right, so there will be a negative charge up here and then a more positive charge down there, making it polar.
Could you draw a nitrate ion?
Nitrate ion. That's the bane of my existence. All right. Nitrate ion. I'm glad, yes, I think that your test is gonna be more on molecular geometry, so I'm really glad that you guys are going through this because it's important. So nitrate. I should ask you guys what the formulas are for the polyatomics, because you guys need to know that, but that's okay. I'm just gonna do it. I feel like I'm getting really repetitive with you guys. 18, 19, 24. Okay. And I mean, probably. Yeah, Devinder, I agree with you. Drawing resin, so- Mhm. Is that what I put on the thing?
I know. It's not polar, right?
What's that?
It's not.
This? I don't think they would ask, he would ask you about ions polarity, because that's kind of a trick question. It's an ion. It has like ion dipole interactions, that's why, yeah.
Out of curiosity, why couldn't you put 2 double bonds instead of 2 single bonds? I don't know.
Lead octet. You can't have nitrogen.
Oh,
Valence. Yeah, no problem, have a good day.
Okay.
Let me know if you need help, send me emails. Send me emails, guys, I'm here for you. Don't bother me so much, but send me emails, okay. I keep jumping around, what was your question again? Oh, yes, N2O4, right? N2O4, okay, let's draw this. Oh. 5 times 2 plus 4 times 6 is 24. 24 is 34. Oh. Okay, so disregard what I say in general. Because I don't want to give you wrong information. He's not gonna ask you about the polarity of something like this. Oh, no, he wouldn't ask. Yeah, he wouldn't ask about the polarity of nitrogen dioxide tetroxide because, alright. Yeah, did I say that right? Dinitrogen tetroxide. Why did I say that? I mean, the resonance forms, right? You can jump here, you can like keep that there, you can jump there. Yeah,
Can you just go over how to do like one of the questions?
Yeah, on here, on your quiz.
oh, did you guys do it already?
No, I'm just looking at it and half of them I don't know how to do it.
Okay, you guys wanna start doing that now? Yes. Quiz, I'll give you guys questions. Here we go. I tried to do Yusuf style and then I decided not to do it, but I want more question. You know how he does like one whole page where it's like a question. And then I decided to just like do a whole. Everyone have a task. Devinder, do you get a test?
Yep.
Okay. Is there anybody on Zoom? Imagine there's someone on Zoom. Yes, no one's on Zoom. Thank God. Okay.
So I'm very happy.
No, because I get because then I have to cater to. Okay. You want to do that right away, or do you guys want to try to temp this stuff?
I did. No.
Oh, how about I'm gonna start the timer and then I'll help you out. Okay, I'm gonna give you guys a timer of, what do you guys say? 20 minutes sounds good? 20 minutes? 20 minutes. All right, perfect. 20-minute timer. Okay. Yeah. So basically this will be the question. It would be a lot nicer, but what you need to do is you need to go look at the molecule and count the carbons.
Oh.
Yeah. Oh, wait. I? Oh, I didn't. I don't care. I'm not fixing that.
Okay.
Yeah, so
So, what do I do? I count.
you count the. So there's 6 carbons, how many oxygens? So you have 6 carbons, right, that's how. Yeah. Okay. And now, what you want to do is you want to use your periodic table and calculate the molecular weight.
I do 12.0.
Yeah, that was a little bit of a tricky question that I gave. I don't think you would get that without giving the formula. And obviously specify the amount of questions specific.
Okay, so then what I. What I just add on.
Yeah. Add them up. Don't say probably, just get the right answer.
Okay, so then how does it do?
So empirical formula is the reduced ratio of the molecular formula. So you actually have the molecular formula like that. So good job you got that right. So you have the molecular formula, right? So it's C6. Yeah. Yeah.
So then. Oh, that. CHC.
Okay. Yeah,
It's just. If you're just reducing them. Empirical is a reduced one.
so because it's,
See.
oh, because, what's it called? You can't like simply reduce it to C H2, because it's, if you multiply everything by two here, right, it'd be C3O3 H4, right, and that's, you can't like reduce three. So, but that would be the answer, so,
C3.
yeah,
I also have to reduce it from the original.
yeah, so like, what can you, like, what's the lower, the highest common denominator?
So then this would be for them. This is gonna be the same.
So what you want to do,
How do I do it?
basically you kind of use these percentages to move these. So this is mass percent, right? So you just kind of take these, you look these grams, so 80.40 grams.
You just make it into gram.
And then what you do is you convert them to mole, and then mole, and you
What
divide.
is in 1 gram?
It's different. So carbon, right? When you look at the periodic table, you see there's a more mass for carbon. And
It's a mole.
so you use all these different things. So
So I do this divided by 4.
you do nitrogen divided by 14.001 or hydrogen divided by 1.00.
Okay, so then also I have a question on this. Whenever you have a negative polyatomic ion,
Mhm.
how do you know if you use Roman numerals or if you use
Mhm. So, so those are two different questions you asked. So basically, with the Roman numerals, like I said,
Yeah,
last week,
that's ion.
that's ionic, but
Yeah.
specifically that's anything that's in like group three with like the exception of zinc, silver.
Yeah.
So cesium is actually in the,
Transition.
no, I don't think it is. Can you go to the periodic table? It's in, yeah, no, I'll tell you, it's out, let's print it out.
CS.
So that's not transition, that's a,
It's a group one.
yeah, so, yeah, that's why it's like that, but, and yeah, that's why.
But it's a metal.
Mhm.
And this is, C is not metal and O is not.
Yeah,
So can't this be considered ionic and covalent?
it is ionic and covalent, but the thing is that this is actually in polyatomic ion that you have to memorize.
Yeah, that I, so if it's a polyatomic ion, they don't have. Most of them don't
No,
have any.
they just,
defects
that's
in
the
them.
name, just use carbonate.
So they don't have any. defects in-
Yeah.
This question. This we didn't learn.
Yeah, you didn't learn that.
Okay. So
You
we're still
learned that.
confused on how to do.
You learned that tomorrow. Yeah. So. This question has got. Guess intuition and the way you draw those structures. You want to take the alpha electron, so 4 plus 3, 6, right? So that's 4 electrons from carbon. That's 3 why it's probably gonna be that way, because it has an odd number.
So moving the stable unit.
Not stable, it's even. I want, we're looking for one that it's not, so,
So
so this one would be like. We have each. On top. Just what I'm working on.
no, but
So, it's a good question, so that's just a methanol, so that's a hydroxyl group. I don't know if you learned it from your bio class, but that's not supposed to be hydroxide, that's just,
so it's not.
no, it's not, it's a way you draw that one. So the way that you draw that. So anytime you see OH in like, I guess like a organic molecule with hydrocarbon, it's not hydroxide.
Okay, so then for all, like to find the emotional amount to see what counts up all the them.
Yeah, that's a good way to gauge that.
So like.
O is maybe 6, yeah. Mhm.
And
Mhm.
how do you find that?
So that means what you want to do is you want to take these, look at the periodic table, take the. So you want to take them and you want to convert them. What I'm showing in class is like a dimensional analysis line. So take grams and then you go, how many like.
Okay, so do I start at 10 grams? Well. Like 12.
Well, the way that I do it, like, this is the way I do it. I would recommend you how to learn how to do it. Just to get it's better. But the way I do it is kind of like not cross multiply, but it's like you want to get cancel out more grams. So
Yeah, so do I put 1 gram and then 20?
you put, sorry, you put a mole for every 1 mole. We have how many grams of.
Oh, I put them in.
Yeah, because then you have to stop the gram.
Okay. So then I'm oh, that's it, that's all I need. And then you do the same thing for zinc and phosphorus, and then the one lowest number is the one that's.
The lowest number of moles, yeah.
And 10 divide.
And then you have to divide it by whatever higher values there.
Would you put in such?
No, keep it like that. How's everyone doing? You guys are locked in? Oh gosh. Not- Okay. There's definitely gonna be a question like this on the test. That you're asking me. Another way to look at this also. Another way to look at it is essentially whichever one has the biggest smaller pass would be the smallest.
But I like this.
Yeah, I know, that way you actually see it, but if you want to get a little more surprised. Yeah.
Like how what families do.
That's why I like using it as a dimension. That's why I like using the dimensional analysis, because you don't need to memorize the formula. You just kind of have to know how to cancel units. So
But do you have like a formula?
that is a formula.
No, like one like.
There is PV equal to RT, but we'll learn that for gas. Yeah. Question 3.
So no one has been, that's when you use this number with the grams centimeter.
So,
Like what we just did.
so, yeah, basically, we wanna count out, this is, that's right. This is what I just, this is what I did on here, right? So you count up, so you count up, right? So then you find between like,
Six,
Mhm.
that divided by the total number.
Yeah.
So then. This question.
it's 97.5. Sounds exact. If it's saying that has zinc and copper, that means that whatever is remaining of this would have to be
Do
copper.
100.
Yeah, and then we want to convert those percentages to grams. Yeah. And then you want to kind of like use a proportion. So like, or depends on what they're asking. So you want to like,
And you do 2.5.
2.5 grams divided by 50. No, because that's not,
Oh, wait, it says that one of copper.
yeah, so this would be the one to find out the grams of copper, the grams of zinc. So you want to actually take the percentages that you have and multiply them by the grams to find out the total grams of zinc and the total grams of copper.
See?
I mean, it's you gotta learn to apply the on my test. Oh, yeah.
But how do I know what percent?
It's not about like knowing the formulas, it's just about like being able to like recognize what you have.
That's what I'm saying. How?
I would say practice makes perfect. Yeah, like that's not such an answer to say, but the more practice you do with these, the more you're gonna be able to identify.
So
what's
I do 97.5 divided by 20.
not divided by. You do 0.975 times 0.0262.
Oh, you're making the desk.
Yeah, that's-
And then you're multiplying.
Mhm.
And then you find out this. Like this.
And then you can use this to see whatever, how many moles of copper and how many well, atoms are. So you're gonna get the grams of copper. Zinc. From there you can see how many grams of something are. Yeah, so that's
Oh,
the
I
work.
didn't know. Okay, so then we have to convert this. This is not gonna.
Oh, that's grams, yeah, you're right. So it's grams and
You're
then,
gonna convert it to mole, you use the.
Yeah.
The mass.
yeah, and then
So
from mole, you can convert that atoms by using. Not just constants. Copper bonds.
See, let's do. Oops. See?
So make sure you put the units there. Something inside.
Yeah.
Questions?
Eh?
Question.
A lot.
You have a lot of questions?
Well, it's just because I'm doubtful of my own work.
You know what?
Doubtful of my own work.
Okay, so turn around.
Um, you don't need a round. I mean, let's look at the answer choices. So, but none of the answer choices here match that. That's a negative, right? So this one's wrong. B would be wrong. So now you
So
want
it says which one's correct, all the wrong.
yeah, all of them are wrong except one,
This
so
is-
B is wrong. So you have to keep doing each of them. Wrong.
Um. For which is probably the least number of atoms. So I feel like calculating all of them individually. So instead what I did, I calculated the molar mass of each molecule. And then I kind of thought of it this way, if it had a smaller molar mass, it had a greater number of molecules, does that work? Or is that probably a concept?
No. Makes sense. I mean, that's a quick way to do it. Yeah, so make sure you check it.
Okay.
But yeah, it should be then. Because when you have the number, and all you do is multiply that out, that just constants, which is the same number for each of them.
Each of them,
Like
okay.
the one that's one would be the one with the largest point.
Mhm. And then
They're all the
for
same.
methamphetamine, right? So I got that as the empirical formula. It said this was the molecular weight. And then I added up, I did the molar mass for this, came out to that. So is it right to just assume that's the same thing? Or is it too
It's a
far off?
typo. It's a typo.
Oh,
No, I made a typo. I made a typo.
okay.
I made a typo. No, guys. Oh, attention. I made a typo. Which question is that?
Number 9.
Number 9. You guys have 55 seconds to fix this up. It's actually 149.23. That's the molar mass. I'm so sorry, guys. Lo siento. I'm sorry if you guys were confused. That's my fault. How are you guys doing? I'm sorry. I'm just like 0 for 4 today, guys. I'm 0 for 4 today. 15, 10, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. New Year! Happy New Year! All right. How was the quiz, guys? I know I made it kind of difficult, especially because I put the wrong molar mass. But how was it for you guys? People, how was it for you? Speechless. That's crazy. All right, so I guess we'll go through this. You want me to go through all the problems?
Just say the answer. But
I don't know the answers.
oh,
I mean, I do know them, but I didn't really.
so I guess
So you don't have an answer key?
I mean, like I do them, I make them, I kind of know the answers, I kind of don't. I know the answers to the methamphetamine question.
Okay, so can you do number 8 and 9?
no, just I want to know every state. I want
He
to
doesn't know that, he has to do them.
I'll just do them quickly. So, for one, rank the molecules, right? So CO, CO2, N2O, NO, and then NO2, right? Okay. Let me just move it so that people can see when I record. Yeah, everyone. I don't know if they'll see that actually. Okay, so off the bat, nitrogen. This will probably have the least one because it's 2 times 14. You want to do the math for all these because then you can triple check your work. You guys are gonna have enough time to check your work. You should at least have enough time to check your work. So, but this has to be. So, let's see. So it's 14.01 times 2 plus 15.99. And then you do this divided by 15.99, divided by 44.09. So this would be 36. That's the percentage. This is the percentage of that's right. That's the question. Oxygen. So you kind of just want to go through it each time. So 12. 15.99. Okay, I'm just gonna tell you the answer for this one because I know the answer. This one would be
B.
B. Looks like it would be B. It would be, yep. All right, does anyone have any objections to that? So, yeah, when you're comparing this and this, what's it called? the nitrogen is larger than carbon. So then because of that, oxygen would have a lower mass percentage. So this would be less than this. And then when you compare nitrogen and oxygen to carbon again, nitrogen has a like it's bigger, so then it would have a lower percentage. So it would be N2O, NOCO, NO2, CO2. Right, that would be great. Okay, anyone have questions about that? Okay. So we got ascorbic acid. I should have put 2 to 8 and 7 because I did not do that. A little bit tricky. I mean, there's definitely gonna be a question on your test where it's gonna give you a molecule. You have to count the sigma bonds or pi bonds, and you're gonna have to know what the symbols mean. Pi bonds, you're gonna know what pi means, but sigma is a little different. Yes, Davinder?
It's unrelated to this question in particular. Do you think he's gonna give like an organic isomer? Because in the slides, I think module pi.
It'll be a very basic organic isomer.
Okay,
So and it'll show you like the thing and stuff like that.
he gave us like C3 H7Br, and two structures were the exact same.
Mhm.
It's just that the placement of the first bromine was different.
Yeah, so you could give you something like basic like that.
Okay.
But anyways, so how many sigma bonds does this have? So you want to count the sigma bonds. You know what? Let me pull it up so I can go through this with you guys. Where is it? Let's see. Email sent. Okay. So sigma bonds, all right? So sigma bonds are all the sigma bonds. So that includes one from the thing. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the answer is A, right? You guys good with that? So, yeah, A is the answer for sigma bonds. All right, and then 3, how many pi bonds? So you want to look at the molecule again. And so you see pi bonds are basically anything with a double bond. If it's a triple bond, how many pi bonds are there? 2. Good, good, good. So 1, 2. So the answer is 2. Very simple questions, but it's important to know these symbols because that's how they're gonna ask on the test. Okay, he's gonna ask like how many symbol sigma bond or pi bond will it be, and you have to know like, oh, that's the sigma star. All right, so what's the electron arrangement and molecular geometry of the 4th carbon? Okay. I don't know why I asked for the electron arrangement and molecular geometry. I might have got a little bit carried away, but what is the answer for this? Is no? It is B. Good job, Spiro. It's trigonal planar. The reason why it is like that is because how many electron domains does this 4th carbon have? It has 1, 2, and 3. So because of that, it's trigonal planar. There's no double bond. I mean, there's no lone pairs.
So 5 domains is trigonal pyramidal, right?
5 domains would be trigonal bipyramidal. That's the electron arrangement. Yeah.
Okay.
All right. What's the hybridization of the oxygen to the right of the 6th carbon? So
Two.
I wrote an arrow there. There's not going to be an arrow on the test, so you guys need to know your left from your right. So what is this? Yes, sp2, right? So you have the lone pair, and then it's connected to the carbon, so it's sp2. Good. All right, and then this one's a little bit. These are a little bit trick questions. Kind of. What are the molecular weights? So what you have to do is you have to count up all the stuff in this. So you gotta count 1, 2, 3, 4, 5, 6. So 6 carbons. There's 6 oxygens and 8 hydrogens. And so because of that, you want to do all the things, and the answer is E. All right. I believe it's something. So there's 6. Let's write that down. 6. It's right here. The molecular formula of absorbic acid is C6H8O6. All right. Everyone good with that?
Yeah.
Okay. So now what you want to do is you want to find the empirical formula. So what you want to do is you want to divide that by the common denominator. So that would be like 2. And so the thing would be C3H4O3. So that's the answer for choice number 8. All right, any question, or 7, any questions? The answer is D.
Oh, okay, yeah.
All right, so this question I made myself. I was really proud of this question, but I made a mistake. So we'll get to that.
Well, either way, I feel like you would have received them. Unless I did it.
Oh yeah, the answer is B. Yeah, you have to, yeah, I guess you could just assume it,
The
yeah.
way that we did it the first time I got the thing.
Sorry. Yeah, so, but anyways, so the empirical formula. You want to convert the percentages to grams. So this is actually, I think it's a good question. So, yeah, does anyone need me to go through the empirical formula, like stuff quickly? Anybody? No? Okay. So you convert the percentages to grams, and then you divide the grams to moles, and then you divide the lowest mole. And so in this case, it would be nitrogen. And so the answer you would get is choice A. All right. So that's the chemical formula of methamphetamine. And then yeah, if the molecular weight of methamphetamine is 149.23, it would be B. All right. So it's the same thing. Okay. Are you guys okay? Are you guys chilling? All right. Okay, so this question was actually on the practice quiz test that I got. So if an unknown ionic compound is found to have 45.4 grams of manganese and 46.2 grams of oxygen, what is its formula? So the way you would want to solve this is you want to convert it's kind of similar to the empirical formula, because all ionic compounds have they are the empirical formula of itself. Yeah. So, this question, right? So what you want to do is you want to take 5.3 grams of manganese. You need to also know your nomenclature. So manganese is Mn, 46.2 grams of oxygen, and you want to divide them both by their molar mass. So what's the molar mass of manganese? Can anyone tell me? 54 point what? 93. 8. And what's the molar mass of oxygen?
15.999.
Okay, so do the math. Let's do the math. I'm doing the math because I forgot the answer. 54.938. And then 46.2 by 15.999. Okay, and then you want to divide by the lowest one. The lowest one is this one. So let's just write that out. So then you're left with 0.824 mole. And you have 2.8 oxygen. Trying to divide this. This is the work you would want to show on your test. Actually, you don't need to show work because it's a multiple choice test. I'm very salty about that, but you don't need to actually show work. So for those that do mental math well, don't do mental math because you might make mistakes. But let's divide it by. I'm talking to you, Devinder.
Oh, come on.
Oh, come on. So then what you'll get is 3.5. And then you would want to multiply this by 2. And then so you get Mn2O7. So the correct answer is E.
Aren't you dividing 0.826 divided by 0.826 and you get?
Yeah, that's what I
So
did.
wouldn't it
can't
just
have a
be M?
Yeah, you can have a 3.5. So if it's 3.5, like if you look at the calculation, it's like pretty close to 3.5. So then you would
Then you
want
have
to,
to multiply to get it, so it's even.
yeah, so you want to multiply it by
By
2.
2, so you get 7.
And then you get manganese 2. So it'd be manganese 7 oxide. That's the name of that.
So is it Mn2O7?
Yeah. So the correct answer is E. All right. 11. This is I gave this question for a reason because this is the question I got wrong on the last test. True or false? CH2I2 is a polar molecule.
Isn't it non-polar?
It is nonpolar, so it's false. So you wanna look at the electronegativity table. Okay, do not go off your intuition, look at the electronegativity table and check that.
I just looked to see if they're metal or.
What? You gotta look at the
For me,
electronegativity.
that works.
That was a lucky shot for this question, because if it was Cl2F2, it would be polar. Yeah, you wanna look at the electronegativity table and you wanna know the values for nonpolar. What's the value for iodine? Can anyone tell me what the electronegativity? For the electronegativity table? 2.5. What's the electronegativity of carbon? 0, so that like the difference of that would be 0. So because of the difference of that is 0, it's practically non.
Wait, but what about the?
Hydrogen? Hydrogen, what's the electronegativity of hydrogen? 2.1, right? Yeah, so it's 2.1. So there's like a slight little thing, but what's the range for nonpolar stuff? It's like 0 to 0.4. Kind of.
Wait, but I'm confused. Are you just
You can take
subtracting?
each one and subtract them from each one.
Yeah, so you take so the molecule that you're writing here is I, right? And you want to use a thing, so there's a dipole of 0, 0. Here there would be a 0.4, 0.4.
It doesn't matter.
Very minimal, but not
Doesn't
super
matter about
polar.
them.
It's very
It
non.
just matters about the electronegativity.
Can you just write out like the subtraction so I can understand because she's confusing.
So
No, you don't make
the
sense.
I would be 2.5. That's the electronegativity.
But it doesn't matter how many, like there's
No, it
two.
doesn't matter
No,
how
it doesn't
many.
matter how many.
So it'd be 2.5 minus then the H then minus.
2.1.
It would be 2.5 minus the carbon. So the carbon is what's connected to it directly. So this would also be 2.5.
So the H doesn't matter either.
H doesn't matter in terms of a bond breaker. So the whole molecule itself, there's not really a high electronegativity difference. Because here, there's a 2.4 kind of thing. I mean, there's a 0.4 difference. And then like
So
here,
even if there was like a thing with like 6 different elements in it, you're only doing it from the central.
yeah, essential to the. Yeah, so it's a lucky question, I know, like, when you're in AP Chem, you don't need to memorize anything, but. I mean, you don't need to like check the electronegativity. It's annoying, that's the question I got wrong. It made me sad, but that's beside the point. Okay, next question. So it's false. All right, which of the following has the same molecular structure as sulfur sulfite? What is that? Anyone tell me yes?
Oh, carbonate. Also, can you draw like CHI? Like a structure of CHI?
CHI?
Yeah.
That wouldn't exist.
No?
4 plus 1 plus 7. That is 11 electrons. That wouldn't be a good molecule. It's unstable. Okay. Anyways, so yeah, so sulfite you have to kind of draw out the molecules. And then see the molecular structure and compare it to the other ones. So you said carbonate would be it? Yeah, it looks like carbonate. 6, 6. That's 24. I don't know if that carbonate would be it. Does anyone have a different answer? NH3, that seems better. That smells better. Okay. Anyways, let's see. SO3. So how many electrons are in sulfur? 6. How many electrons are in oxygen? 6, right? How many electrons I mean, 2 extra electrons because of the charge, so that's 26, right? 26 total electrons. Okay, so then sulfur, want to draw the bonds. Could be probably like this. Okay, so how many electrons have I used?
24.
24, so then you put a
Two on the
double
middle.
bond here. I already put a lone pair there, so it has an AX3E1 thing, so it would be trigonal pyramidal. And so the only one that would answer that is ammonia, which is B. All right. Okay. I'm glad that this test is going okay. Yes. Which one? Yeah, because of four, it would be 4 minus 2.5, which is in the range of it being polar. So yeah, I'm giving you guys a tricky question because I want you guys to make sure to check the electronegativity value so you don't get a dumb question wrong. Because that's a sad question. You just have to check the electronegativity and see the difference or whatever. But anyways, what is the correct name of this molecule? Can anyone tell me this is based off polyatomic ions? Spiro, would you like to give it a shot?
Ammonium sulfide.
Yeah, that's good. That's good. So what's the molecule, what's the polyatomic ion for sulfate? Anyone tell me what that is? Yeah, so for what? 2 minus, good, very good. What's wrong with C? Yeah, Roman numerals. When do you use Roman numerals? Transition metals, right? What are the exceptions that you said in class?
Silver, zinc.
Silver, zinc, cadmium. They actually make like a little L, I think, on the periodic table. So that's a way to memorize it. It's like, I don't know where it is. Can I see the periodic table? Yeah, they make an L. I mean, a backwards L. So it's like Ag, Cd, zinc. So that's a way to memorize it. Okay. I need a periodic table. That's the moral of the story. Okay, so this question's a little bit tricky. This question was on the last test. Which of following has the least number of atoms? Anyone like to tell me? Not A.
No, but
I already know your answer. Wait, but would you like to tell us?
Yes, that's fine.
What'd you say? You said E?
D.
E? It's not D. What's that? Yeah, it's E. So to do this the long way, you want to you guys have any plans for Halloween?
What?
Oh yeah. You guys have a no, I mean your test is after like
then we have tests after
what
that.
do you have what
Biology next week.
when?
And we have
Thursday.
health tests on Monday.
Oh,
Yeah.
oh, I don't have any tests next week. I'm so happy. Okay, that's nice. Sorry. Sorry guys. I'm sorry guys. Anyways. Okay, that was a little unprofessional. 10 grams of everything. So it's all the same grams. You just need to make sure you have the molar. The thing that changes between each of them is the molar mass, because if you were to convert these to grams, to molar mass, right, you would have the 1 mole over some molar mass times, what's it called? 1 mole over 6.023 times 10 to the 23, right?
Yeah, I did that, but I didn't get that answer. So
Yeah, so basically the only thing that's changing here would be the molar mass. And so because of that, you want to actually choose the one with the highest molar mass. Because the highest molar mass will make this whole thing smaller. And so, I mean, that's a mathematical way. You could also just look at the moles and see which one has the lowest number of moles as well. That's probably what I would want to do for this question, or I would do what I just said. So with bromine, it's 75 times 2, right? What's the molar mass of bromine? Anyone tell me? 79.904. Wait, what'd you say? 79.904 times 2. So that's the biggest one. Fluorine would be. Oh, I need a periodic table. This is, something. I should stop telling you guys to get a periodic table because then I should get my own periodic table. And then you guys can learn from me. So yeah, I'm not gonna really dwell on this, but basically the highest molar mass would be bromine. And so then if you were to use this formula kind of to solve this, you would see that this one would be the smallest one. Because yeah, you want to convert this to moles. And yeah, this question could become a lot more trickier than it needs to be because it's asking about atoms and you get big numbers and you're like, how do you compare these numbers and whatever. So yeah. Okay, gonna get moving on. Which of the following substances would you expect to have the highest melting point? Question mark. Is it what? It is A. So ionic compounds generally have higher melting points, higher boiling points, and they are very conductive. So that's these are qualities, these are characteristics of ionic compounds you're gonna need to know for the test. You could ask any of those questions and you gotta know them. All right. What is the molecular geometry of sulfur dibromide? I don't know. So what's the I'm not gonna ask you guys. Let's do this. Sulfur bromide. Dude, you need to be able to write this out because that's how you answer the second question. So you would do sulfur PR 6 plus 7 times 2 equals 14, 14, 20. Adding 1, 2, 3. Next. So it is bent. So you guys, you got it. You got it, man. Yes. What is this very similar to?
Water.
Water, good. And then also similar to H2S as well, which is right. It's up there somewhere. H2S is on the 14th question. Okay. And then you want to find the molar mass of this. So can you tell me what that answer would be? D, probably right. So you want to take 79 times 2 plus 32. And yeah, it's D. All right. Anyone have any questions about anything in life? How are you guys feeling about this test? How was the quiz? Besides the little hiccup, I think it's okay. Yeah, I know this quiz was a little tough when I was making it because I was like, oh, this is kind of tough. Yeah, because well, you guys, like I said at the beginning of the year, you guys need to learn these concepts well. You also need to learn to apply these concepts in these different questions and stuff like that. And so, yeah, practice makes perfect. So, if you guys if you guys are asking me advice about doing these questions, practice makes perfect. All right. The only reason why I have like the intuition to do these questions is because I practice a lot. So, yeah. Have a good day. Please let me know if you guys have any questions yet. There's only one professor, and it's William Letzwell. And you guys are gonna take it in this room. You guys are gonna realize how sad your life is. Yeah, it is what it is.
I have to be here at 8 in the morning.
Is that 8?
I think so. I have to check.
No, I think that's psychology.
Also, is it? Oh, okay.
Yeah, if you guys have questions about scheduling, let me know. I got you guys. Okay. I know that I know that everyone says that she's scared. I mean, I think she's a really good teacher. She's probably one of the better teachers here. She's just a little strict, that's all. In terms of like, pay attention. Don't don't be filled out. Yeah, but like she's like engaging, kind of like you're acting. That's what a good word is to describe that. Yeah. Anything else? You guys are just chilling. Do you guys like the quiz?
Yeah.
I'm sorry about the 149. I'll change it. I'll send a new one. I'll make a better one. I'll make a better one next Wednesday. Oh yikes! A lot of people are gonna come next Wednesday.
Leaving early.
Hmm?
I'll be leaving early on Wednesday.
Um,
I'll watch a concert.
before the chem test.
It's at our high school.
Oh, so like
It's like
the
the-
winter concert or something.
Yeah. I don't know. I felt like it.
You're in the band.
Chorus.
Oh yeah, you told me. I was in the band. I was a band kid.
What instrument?
Clarinet. Why you guys can leave. You guys just standing here and will ask any questions. I mean, you guys can stay if you want. I'm just gonna start packing up. I'm sorry. I don't mean to kick you guys out.
Thank you.
Thank you, Spiro. Have a wonderful day. You guys have more questions? No?
Nah.
You guys are just lingering? I have lingerers. Crazy.
I was tired.
I know, I'm tired too. Bro, I was so nervous. Like, I was sitting right here and the test, we had our oral test getting back. We were getting our oral test back. and like I could see the tests, and I was like, my heart was like pounding. I was just like, you know how they like make you wait until the end of the period? to
Yeah.
get the test? Yeah,
You know, Haji did that after our first test. He's like, I'm not giving you guys back until we finish a lesson.
I know, and it's like so annoying. And I'm just sitting here, right? The tests are right here. I see a whole pile of them. I see one test on the top that's like marked crazy, and I'm like, oh no, guys. And then like she was going through the test. She was like handing out each thing, and she's Indian, so she has like an accent. So she's like, "Your, Abigail, Gavin, whatever, right?" And she keeps going through all these names, and then I don't see like she's not calling my name. And I'm like, my heart's just like pounding, and then I was like the last one, and she's like, "Oh look," she gives it to me. She gives it to me. It's sad. It is what it is. But yeah,
Maybe your SI or so.
I don't know. Why? Do you want me to?
Yes.
The problem is, right, is that I'm taking Lahankart this semester. So I don't know if Lahankart will be teaching the BSDOs next semester. That's the problem. So if I am good at Orgo, which I am doing good right now, the reason why I'm the Yusuf, like the reason why I'm the chemistry SI for Yusuf is because I took his class and he was my teacher and he recommended me and I asked to do it. And so then like there's a mutual thing. But if you guys have Fiorito as your Orgo SI, then things get a little wonky because then it's like I can't really teach that because it's a different teacher and stuff.
Mm.
Yeah. I'll probably do the Gen Chem again and then do Gen Chem 2. I'm sorry, guys. Don't look at me like that. I'm sorry. I'm sorry. I can help you guys for Gen Chem 2.
Yeah, was it biostats?
You know, okay, wait, let me turn off the Zoom. Let me turn off the Zoom. So you guys, oh yikes, sorry guys.